a look at a more realistic problem of something we would see every day. If you ever buy a lottery ticket, on the back of the lottery ticket, there's your odds of winning, and it's usually like 1 in something ridiculous, some crazy looking number, and you're always like, how did they come up with that? Well, that's what we can talk about here in this next problem. Okay, on this next one, we want to calculate the probability of winning, let's say, the South Carolina Powerball lottery. The first part of winning the lottery is that you have to match 5 numbers from 1 to 55. So what we'd start out with is, how do you match 5 numbers? Well, first of all, the question would be, does order matter? So let's give an example again. Let's suppose the winning numbers of the lottery are 1, 2, 3, 4, and 5, but on my ticket, so these are winning numbers, but on my ticket, I have 5, 4, 3, 2, and 1. Doesn't matter. I did actually get the 5 winning numbers. So, does order matter? Absolutely not. I won. I matched the 5 numbers. I matched all 5, so I won. So order does not matter, which means because order does not matter, we're going to use combinations. So we're going to use combinations. Okay, which means we're going to use our big C here. And let's see, what's our total? Well, we have the numbers 1 to 55, which means there's a total of 55 numbers to choose from. That's a lot. How many are we choosing? Well, we're matching 5, so we need to choose 5. And again, this is definitely one we're going to want to use our calculator for. So our calculator, let's see, will come up with the following. If we're choosing from 55 things that we want to choose 5 of those numbers, what we end up with is a very large number of 3, it looks like 3,478,761. The problem is this is only part of what is the lottery to actually win the jackpot. It also says that you have to match the Powerball. Well, matching the Powerball is any number from 1 to 42. However, that's only just one thing you have to do. So you also need to match one number of between 1, 2, and it was 42, which you can do this shorthand if you want. If you're matching one number between 1 to 42, there's only 42 ways to do that, because you choose one of the 42 numbers, or you can do the same thing that we just did, that there's 42 numbers and you're choosing one of those. Order doesn't matter, and you'll get 42 as well. It's really up to you. It doesn't matter either way. But now we have to put these two ideas together. We have matched the Powerball, which was, that was the second thing that we did, which there are 42 ways to do that. And then we have matched our 5 original numbers, which there are 3,478,761. Now we actually have to put these two ideas together. So you want to do both of these. You want to match the 5 and, is the key word, hit the Powerball. So there's 2 things that we're doing. Well, we just said that the matching of the 5, that there were, 3,478,761 ways to do that. And winning the Powerball, we just discussed that there were 42 ways to match the Powerball. So how do I put these two together? Well, I want both of them to happen, and they are together with an and, which means, remember, if you go back to the beginning of probabilities, is when you have the word and, you are going to multiply. So what happens when we multiply the 3,478,761 and the 42? We're going to get something really big. Using our calculator, what we end up with is the following. When we multiply those two out, is we end up with, let's see, if I copy it off the calculator, it's 146,107,962. So putting our commas in there, that's 146,107,962. And that's just how many different possibilities there are. So this is possible lottery tickets. That's ridiculous. However, we're still not done. How do we actually find the probability of winning? So we want to find the probability of actually winning. The problem is there's only one winning ticket out of those possibilities, out of the 146,107,962 tickets. So that is the problem. So when you go to look at the back of your lottery ticket, they'll say your chances of winning are 1 in, and here's your crazy number, is that denominator. And it does come from somewhere, and it is legitimate, and this is how you'd come up with it. Now, they might want you to also convert this into a decimal, in which case you take 1 divided by this number and plug it into your calculator. If you're worried about retyping it, there is an answer button on your calculator, so just remember the last thing that you typed in. And it's right where the, let's see, the little negative sign is at the bottom of your calculator. It's right here. And if you actually look, you can see the answer. And you have to hit the second key first. So you do 1 divided by, and then you'd press the second, and then you'd press the negative sign, and it would type in the answer option. And notice what we get for our final answer here as a decimal is very, very small. It's 0.0000000007. Now, it's very easy to accidentally copy this from your calculator into my math lab, and if you miss one of the zeros, it will mark you wrong. So it is a very, very, very good idea to go ahead and write down your fraction on your scratch paper that you're going to submit, so that I can give you partial credit in case you do miskey this in. Another thing, some calculators would write this in as 7 E, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. -9, which is actually scientific notation. So this would translate to 7.0 times 10 to the -9. And what that is telling you is that to come up with the decimal answer we just came up with, you'd have to take 7.0, and that -9 would be telling you to move your decimal place 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you'd have to fill all of your empty spaces with zeros to come up with the answer that we came up with. And it just depends on your calculator, but it does give you the exact same answer. It's just written a little bit strangely, and it just depends. It's just a reminder to something that you covered way back when in an algebra course called scientific notation. One last problem here.